I will take d by dx of sin square x once again, because some portion of this d by dx of sin square x is not visible on the board. Here it is d by dx of sin square x. So I did that one, but some portion of this derivation was not visible on your screen because it was written at the bottom of the board. It is equals to, it is d by dx of sin x the whole square. Sin square x should be taken as sin x the whole square. So here it is of the form f of x raised to n. What is f of x here? Sin x. What is the n here? 2. Therefore the answer is d by dx of f of x raised to n. The differential coefficient is n into 2 into f of x sin x raised to n minus 1, 2 minus 1 into d by dx of f of x. F of x is sin x. Which formula is taken here? D by dx of f of x raised to n into f of x raised to n minus 1 into d by dx of f of x. That's equals to 2 times of sin x raised to 2 minus 1 is 2 minus 1 is 1, sin x raised to 1 is sin x, a raised to 1 is a. What is the differentiation of sin x? Now we have to differentiate sin x. Sin x differentiation is cos x. Now 2 times of sin x cos x, that is nothing but sin 2x. Trigonometry formula, sin 2x is equals to 2 times of sin x cos x. Okay. Now let us take some more composite functions differentiation. So sin x, look here, sin x, cos x, so on, or even tan x, sec x, cosec x, cot x, or simple functions, or you can call it as single functions. The differentiation of sin x d by dx of sin x is cos x, d by dx of cos x is minus sin x, tan x is d by dx of tan x is sec square x, d by dx of sec x is sec x into tan x, d by dx of cosec x is minus cosec x into cot x, d by dx of cot x is minus cosec square x. Simply here only x's are there. In place of x, any equation of x is there, then it will be treated as composite function. Okay, explainably some equation of x, even explainably, even in place of x, minus 6 by 2 is there, then also it will be treated as a composite function. Okay, when minus 6 is there, place minus 6 is there, then also it can be taken as a function of x, f of x. Okay, mind it point. An equation in x, or what it is, even minus 6, x by 2, etc. are to be taken as f of x. Now, one by one, therefore sin f of x, okay. Mind that one again and again I am telling f of x may be an equation in x, a function of x. Any type of function it may be logarithmic function, for example, f of x is log 2x plus log 3x, etc. Or f of x may be exponential function 2 raised to x plus 3 raised to x, etc. Or f of x is trigonometric function sin x plus cos x, etc. Or f of x may be a logarithmic exponential, polynomial function x square plus 2x plus 5. F of x is equals to minus 6 is also a composite function, or along with the x. Even when constant is there, then also it will be treated as a function of x. Okay, sin f of x, cos f of x, etc. are composite functions, or composite functions, or composite functions. Okay, now let us take d by dx of these composite functions. Look here, d by dx of sin f of x is equals to sin differentiation. Look here, d by dx of sin x is cos x, sin x is equals to cos x. Similar to that, simple function derivation, composite function differentiation will be there always. Now sin differentiation is what? Cos f of x, but into an extra factor d by dx of f of x. Okay, always in the composite function differentiation, into d by dx of f of x, an extra factor should be multiplied. Okay, second one, d by dx of cos f of x. Before that one, I will write d by dx of cos x. What is the cos x differentiation? Minus sin x. Here also same. It is minus sin f of x into d by dx of f of x. Okay. Third one, d by dx of tan f of x. Before that one, I will write tan x differentiation. D by dx of tan x. What is the tan x differentiation? Sec square x. Therefore, tan f of x differentiation sec square f of x into d by dx of f of x. Okay. Into d by dx of f of x is additional as compared to the simple. Okay. And d by dx of fifth one, let us take cot f of x. Before that one, I will write d by dx of cot x. What is the cot x differentiation? Only x is there here. But the difference here is here x, here some equation of x. Same formula of differentiation, but an additional factor into d by dx of f of x. Okay. Cot x differentiation is minus cos x square x. Therefore, cot f of x differentiation is minus cos x square f of x into d by dx of f of x. Fifth one, d by dx of sec x. Sorry, sec f of x. But d by dx of sec x is what? Sec x into tan x. Sec x into tan x. D by dx of sec f of x is, it is sec f of x into tan f of x into d by dx of f of x. Okay. Sixth one, d by dx of cosec f of x. Cosec x differentiation is minus cosec x into cot x. All C differentiation in trigonometric function are negative. Cos minus, cot minus, cosec minus. Okay, remaining three are plus. Therefore, it is cosec f of x minus cosec f of x into cot f of x into d by dx of f of x. In short, d by dx of f of x can be written as f dash of x. D by dx of f of x can be written as f dash of x. Mind you, d by dx of f of x can be, in short, can be written as f dash of x. Okay. F dash of x means d by dx of f of x. Okay. Let us take some problems on the differentiation of trigonometric composite functions. Okay, one by one let us take. Differentiate the following with respect to x. Differentiate the following with respect to x. Try to understand these differentiations. Once you understood the differentiation of composite functions, then actually differentiation will become an easy process. Okay, and the entire differentiation topic will become simple. Okay. Differentiate the following with respect to x. The following with respect to x. First one is sin 3x. Second one is cos 4x plus 5. Third one is tan of sin x. Fourth one is cosec of e raised to x. Fifth one is sec of x by 2. Okay. Sixth one, cot of x square plus 2x plus 5. Okay. Cot of x square plus 2x plus 5. Seventh one is sin x degrees. Eighth one, tan x degrees. Okay, one by one let's take. X degrees. First one is sin 3x. Differentiate the following with respect to x means you have to take d by dx. D by dx of sin 3x. Look here, it is simply not sin x, sin 3x. Therefore, f of x is here is 3x. F of x is 3x. Okay. Every time writing f of x is unnecessary. A side whatever written in the side is not necessary. Okay. So it is, my mother tongue is Kannada, therefore sometimes, okay. So I will speak in Kannada. Okay. So it is 5, f of x is 3x. That is, what is the sign f of x differentiation here? Cos f of x into d by dx of 3x. Therefore it is cos 3x. What is the differentiation of 3x? 3 into differentiation of x, 1. 3 constant outside, differentiation of x, simple differentiation. Therefore the answer is 3 cos 3x. Second one, d by dx of cos 4x plus 5. Okay, it is cos f of x. What is the f of x here? Cos x is not there, but in front of cos, some equation of x is there. Therefore it belongs to the category of cos f of x. Here f of x is 4x plus 5. Okay. And therefore, what is the cos f of x differentiation? Minus sin 4x plus 5 into d by dx of 4x plus 5. Here f of x is what? 4x plus 5. Now, cos differentiation minus. Okay, cos differentiation minus sin. Simply x is not there. In equation in x is there, means f of x is there. Therefore, sin f of x into d by dx of f of x. This additional term is to be taken. If simply x is not there, and equation in x is there, same formula of differentiation into d by dx of function of x should be taken. Now 4x plus 5 differentiation I have to take. Sin 4x plus 5 as it is, d by dx of cos f of x minus sin f of x, you get the formula, into d by dx of f of x. Now 4x plus 5 differentiation. For 4 into differentiation of x, 4 constant, no, outside. Differentiation of x is 1 plus differentiation of 5 is 0. Whenever plus or minus is there, you have to differentiate plus or minus is there, you have to differentiate each and every terms. For d by dx of 4x plus d by dx of 5, try to understand simple differentiations. So d by dx of 4x, 4 constant outside, d by dx of x, 1, plus d by dx of 5 is pure constant differentiation is very easy. Okay, it is minus 4 into sin of 4x plus 5. Pure constant is only constant. Pure constant in the sense only constant. Okay. No equation of x is multiplied with constant, only constant. Then I call it as pure constant. Okay. And third one, d by dx of tan of sin x. D by dx of, I have to take d by dx because if you look at the question, differentiate the following function with respect to x. Differentiation with respect to x means you have to take d by dx. Differentiate it with respect to theta means you have to take d by d theta. Okay. D by dx of tan of sin x. Tan of sin x. Composite function. Pronunciation will be like that. Tan of we are getting. F of g, g of f of means a bracket. So whenever of we are reading, you have to understand it is a composite function. Okay. It is f of x in what here? Which one is f of x here? Which one is f of x? Sin x is f of x. Therefore, what is that? It is in the form of tan f of x. Tan f of x differentiation. Tan differentiation is x square. Therefore, it is x square sin x into d by dx of f of x sin x. Okay, that is x square sin x. What is the differentiation of sin x? That is cos x. That's all. Now next one, d by dx of which one? Cosec e raised to x. Cosec e raised to x. Cosec e raised to x means it is in the form of cosec f of x. Okay, in place of cosec x is there, is simple. In place of x, e raised to x is there, the equation in x, therefore it belongs to the category of cosec f of x. Okay, now this fifth one, fourth one, d by dx of cosec e raised to x. So it is the form cosec f of x. So here f of x is e raised to x. Cosec only x is there, simple function. cosec in front of that one, some equation of x is there, then it is function of x, cosec f of x. Now the cosec differentiation, minus cosec f of x into cot f of x is e raised to x, no? Into d by dx of e raised to x f of x, cosec f of x differentiation minus cosec f of x into cot f of x into d by dx of f of x. F of x is e raised to x here, f of x is e raised to x. Okay, e raised to x differentiation is e raised to x, therefore minus cosec e raised to x into cot e raised to x. There is no need to write into a into b, it is better to write into. When into is necessary, actually, suppose instead of a into b, both are numbers, then it is 2 into 3. Both are numbers, it is better to put into there. Otherwise, for algebraic terms, for any functions terms, no need to mention into. Understood? A b means a into b. Okay. Cosec e raised to x into cot e raised to x. What is the differentiation of e raised to x? E raised to x only. Better to take e raised to x in the beginning. E raised to x, cosec e raised to x, cot e raised to x. Okay, that is the differential coefficient of, this is the differential coefficient of cosec e raised to x. The process of getting the differential coefficient for a given function is called differentiation. This is the differential coefficient of this particular function. The process of getting the differential coefficient for a given function is called differentiation. Okay. Next one, fifth one, d by dx of sec x by 2. So here, f of x is x by 2. F of x is what? X by 2. So here, f of x, simply x is not there. In place of x, x by 2 is there. I told you, along with x, even minus is there, or constant is multiplied, that should be taken as f of x. Okay. So what is the sec differentiation? Sec into tan. Or simply write down sec x by 2 into tan x by 2. Since simply x is not there, x by 2 is there, therefore you have to multiply d by dx of x by 2. It is sec x by 2 into tan x by 2 into what is the differentiation of x by 2. In x by 2, 1 by 2 quotient formula is not necessary. 1 by 2 is outside into d by dx of x. It is 1 by 2 outside into d by dx of x is 1. Understood? X by 2. Quotient formula is not necessary. X by 2, 1 by 2 is constant. Whenever in quotient formula u upon v or in product formula u into v, a constant is there. Better to take constant outside. That's equals to 1 by 2 outside d by dx of x. That's equals to 1 differentiation of x is 1. Therefore, it is 1 by 2 sec x by 2 into tan x by 2. And next one is cot x square plus 2x plus 5. Cot x square plus 2x plus 5 d by dx of 6th one d by dx of cot of x square plus 2x plus 5. Here f of x is cot differentiation. First of all, it is cot differentiation. Minus cosec square x square plus 2x plus 5. Cot differentiation minus cosec square. Here it is f of x into d by dx of x square plus 2x plus 5. That is cot f of x differentiation minus cosec square f of x into d by dx of f of x. That is minus cosec square x square plus 2x plus 5. Tell me what is the differentiation of x square plus 2x plus 5? X square differentiation is 2x plus 2x differentiation 2 into 1 plus 5 differentiation is 0. Plus or minus is there, you have to differentiate each and every terms. Now 2x plus 2 better to take it in the beginning. Minus 2x plus 2 into cosec square x square plus 2x plus 5